Hello, everyone. So in this video, we're going to be reviewing how to simplify radicals with variables. So we'll review the basic procedure, go over a few examples, and I'll have some for you to try on your own as well. So these first two are just to explain the procedure. So remember, if I'm going from root form to exponent form, I divide my exponent by my index. So if it's a square root in this first one, it's divisible 2. So if I do exponent over index, so basically divide each of them by 2, it would look like this in exponential form, since they're both under the root. So if it's even, it's a pretty straightforward procedure, just divide by 2. So that would be my answer. One minor note, just a side note, we did mention that since these are variables and their value can vary, take on whatever value. If I did have a negative here with an even exponent, I know every two negatives cancel to positive, so even would make it positive. So when this cancels, we just have positive y here. So I'll never get a negative out of a square root, because if I take the square root of negative, it would be imaginary or not, we would have no real root. So we're not taking into account the negative value here. So we said, if I do have two evens that give me an odd exponent, that's when we do need, or that's when you would see, technically there should be an absolute value there, because we're only accounting for the positive root with this one. But we're not going to worry about that, like I said. So that would be my answer, just a side note there. Okay, so even with higher ones like a cube root, so if I change this to exponential form, so if I divide both of these by 3, and you don't have to show the dividing by 3, but if you divide this by 3, 6 divided by 3 would give me 2, 15 divided by 3 is 5. Okay, so it works with higher ones too, and since it's odd, we don't have to worry about any of the negative variations, because if it was negative, it would just stay negative. So negative roots are okay with odd indices. Okay, so moving up this procedure to non-even exponents, we said if I were to divide, 3 does not go into 11. So 11 over 3, I can't simplify. So we said in order to simplify these ones, we basically want to split it up. Okay, so we basically make two radicals, just like we did with square roots, the stuff that gets to come out and the stuff that doesn't get to come out. Okay, so 3 doesn't go into 11, so I bring 11 down. So I could bring the number down until I get a number that 3 does go into. So if I bring it down, 3 doesn't go into 10, but 3 goes into 9. So I could bring this 11 down to a 9, which means we brought it down 2 values, so we have 2 left over. Okay, so 3 goes into 9, so this will get to come out, and the stuff that doesn't get to come out, we'll just throw in the other one. Okay, for the y, 3 does go into 6, so I don't need to bring that one down, so I could just keep the y to the 6, I don't need to split it up. Okay, and 3 doesn't go into 16. Okay, so I want to bring that down to the closest number that 3 does go into, so if I bring it down just to 15, 3 does go into 15. So I could bring that down to 15, which means we just have 1 left over. Okay, so notice I still have 16 z's altogether, 15 and 1. So we're just splitting it up, we're not changing anything. So now I made this radical of everything that is divisible by 3. So if I divide these by 3, these would all get to come out. So 9 divided by 3 is 3. 6 divided by 3 is 2 for the y, and 15 divided by 3, 15 divided by 3 is 5. Okay, so all those would get to come out of the root, the radical, and then this one would just be stuck inside. So x squared z would be stuck inside. So that would be my simplest form. Alternatively, we said you could do it with how many times it does go into the remainder. So for example, 3 goes into 11 3 times with the remainder of 2, right? Because it goes 3 times 3 is 9, so remainder 2, so the 2 is stuck inside. 3 goes into 6 twice, no remainder, so no y's in the inside. 3 goes into 16 5 times with the remainder of 1, so remainder of 1 on the inside. So you can see how many times it goes in, how many times that number goes into the exponent, that goes out on the outside, and the remainder will go in the exponent on the inside. So you can do it that way as well. Either way, we'll get the same answer. Okay, so if I put numbers into here, so with the numbers, you can just do it the normal way with the factorization, make the tree. But you should have, for cube roots, you should have the basic ones memorized, maybe not 6, but 2, 3, 4, 5. So these 4 cubes you should have memorized. So it's easier to guess and check. So if I make my 2 roots, so stuff that gets to come out, stuff that doesn't. Okay, so 135, I would just check which one of our roots go into it. So 8 decimal, so 8 doesn't go into it. If I check 27, quit that. So 135, if I divide that by 27, it does go into 27 times 5. So 27 is a perfect cube. So you could break that up into 27 times 5. Or if you were to break this down, you'd get a group of threes, 3 times 3 times 3, and then a 5 left over. So you could split it up like that as well, and a group of 3 would get to come out. But I think this is a much more efficient way of doing it, seeing which one of our, because once you get to like 5, it's too big. So you most likely will only need the first few here. So that works well. Okay, so 3 doesn't go into 13. So if I bring the 13 down, the next number underneath is 12. So 3 does go into 12. So I could bring that down to 12, which means we just have 1 left over. So we still have 13 altogether. Just split it up. 3 does not go into 8. So I bring that down. 3 doesn't go into 7. 3 goes into 6. So I could bring that down to be to the 6th. Okay, so all these get to come out of the cube root. These are all divided by 3. And then we need 8 altogether. So that means we have 2 left over. So 2 left over. Okay, so the cube root of 27 is 3, right? Because 3 times 3 times 3 is 27. So that's 3. If I divide the 12 divided by 3, changes to exponential form. 12 divided by 3 is a to the 4th. And 6 divided by 3 is b squared. So those all get to come out. And then this one I'll just copy down. These are all stuck inside. Those don't get to come out. And you should notice the exponent should always be lower than the index, because if it was 3 or higher, 3 would go into more, right? So these will always be either 1 or 2, because remainder is 0 means it goes in evenly. So that's just nothing, right? I think the 0 power is just 1. So this would be my final answer. Okay, so make the 2 radicals. 1 does get to come out. Everything here is just stuck inside. So you just put the leftovers. That does nothing much to do with that one. Okay, let's look at one more. Okay, so the cube root of 32, x 21, y 27, y 17, z to the 20th. Okay, so if you look at our perfect cubes, well, 27 obviously is too big to go into 32. So 32 is 8 times 4, right? So you could do that one in your head without the calculator. So you'd split that up. So the cube root of 8, 2 times 2 times 2 gets to come out. 4 would be just stuck inside. Okay, so that would be easier. If you wanted to do something like this, this is 16 times 2, 4 times 4, 2 times 2, 2 times 2. So remember, every group of 3 gets to come out. So you could put these 3 here. So 2 times 2 times 2, which means you'll have a 2 times 2 left. So that's not in a group of 3. That will get to come out. So if you do it with the tree way, you'll get the same answer. Put any groups of 3 here. The leftover goes there. So either way with the numbers, if you have the 827 memorized, it's very quick. You could just do 8 times 4 and you're done with the numbers. Okay, 3 does go into 21, so you don't need to do anything with the x's in terms of splitting it up. Okay, 3 doesn't go into 17, so let's bring the 17, but bring down to 16. 3 does not go into 16. 3 goes into 15, right? So I can make that y to the 15th, which means we have 2 more. We need 2 more y's in order to have 17 total still. Okay, 3 doesn't go into 20, so 19, now 18. So I could bring that down to 18. Which means we need 2 more to get back up to 20. Okay, so everything in here gets to the cube root of 8, we said is 2. 3 goes into 21 7 times, so 21 divided by 3 is 7. 15 divided by 3 is 5, and 18 divided by 3 is 6. Okay, so those all get to come out, and then this one is all stuck inside. So 4y squared z squared, those are all stuck inside. Okay, so that'll be my simplified form of this root. Okay, let's look at a 4th power one as our last one, and then I'll have 2 for you to try. Okay, so 4th power, harder to memorize. So 96, so if you just guess and check, so like 2 to the 4th, because once you get to the bigger numbers, it gets too big. So 16, so you can check if 96 is divisible by 16, which it is. Okay, so 16 times 6. Okay, so if I break this up into 16, so 16 times 6, so 16 is 2 times 2 times 2 to the 4th. So that will get to come out. If not, you could try 3 to the 4th, but 3 to the 4th, like I said, it's already too big. That's already 81. So clearly 81 doesn't go. So everything else is too big. So that one shouldn't be too bad. Okay, 4 doesn't go into 14. So let's bring it down to 13, no, 12. So 4 goes into 12. So I can make that m to the 12th, which means we have 2 more. Okay, 4 doesn't go into 7. So 6, 5, I would have to bring that down to n to the 4th, right? Which means we have 3 left over. Remember, everything in this stuff that doesn't come out should be less than the index. So 3 is less than 4, so we are okay there. Okay, and this got erased, but I think it was 25, I believe. Okay, so 4 doesn't go into 25, so I bring that down to 24. So 4 times 6, so 24 would work, right? Which means we have just 1 left over. Okay, so let's simplify this group. So the 4 through to 16, as we said, is 2. So 2 times itself, 4 times give you 16. 12 divided by 4 is 3. 4 divided by 4 is just 1, so I could put the invisible 1 there. And 24 divided by 4 is 6. Okay, so that all gets to come out, and then if I copy this group, this all would be stuck inside. Okay, so nothing to do with that second group, so that'll be my simplest form of this one. Okay, so make your 2 groups, everything that gets everything, all the exponents divisible by 4, and the perfect 4th roots, everything left over in that one. Okay, so I want you to take a moment, try these 2 on your own, see how we do it. We'll go over the answer in just a moment, so pause the video, try these on your own. And once you have your answers, you could play it and we'll check them in a second. Okay, so at this point, you should have gotten your answer. So 5th through to 96. Okay, so if you guessing, not guessing, but if you check 2, because once you do 3 to the 5th, it's already way more than 96. So this is our only option. So you should have a group of 5 2s, which is 32. And 32 times 3 gives you 96, right? Because 3 times 3 is 9, 2 times 3 is 6. So that'll be 32 times 3. Okay, so 32 times 3. Okay, 5 goes into 10 evenly, so nothing to do there. Don't need to break that up. 5 doesn't go into 18, so you could bring that down. So 17, no, 16. So 15 is the closest number there, which means you need 3 left over to get back up to 18. Okay, 5 doesn't go to 24, so you have to bring that down all the way to 20, right? Because 23, 22, 21, 20 is needs to be a multiple of 5, so 20 would be the closest one there. Okay, so it looks like you have 10, 15, 20 here, but you have 4 left over for the Z's, so 4 left over. Okay, remember this group, nothing you could do with, they're all no groups of 5, they're all less than 5. Okay, so nothing to do with that group. So if I simplify this one, so the 5th through to 32, as we know, is 2. 10 divided by 5 is 2. 15 divided by 5 is 3. And 20 divided by 5 is 4. Okay. And don't leave that much space in between. You could move these closer, but that'll be your answer there. Okay, and for this one, 4th root of 162. Okay, so we already had 2 to the 4th on here, 16. So you could check if 162 is divided by 16, which it's not. Okay, so you could try 3 to the 4th, which is 81, and that's half of 162, right? 81, 81. So it looks like 81 and 2 is how you could break this one up. So 81 and 2. Okay, 4 doesn't go into 21, so you bring that down just 20. That'll work, which means you have 1 left over. Okay, and 4 doesn't go to 15, so if you bring that down, so 4 doesn't go to 14, 13, so you have to bring that all the way to 12, right? 4, 8, 12, 16, so 12 is the 1 multiple. Okay, so you bring that down to 12, which means you have 3 left over, so you still have 15. Okay, so the 4th root of 81, as we know, is 3. 4 goes into 25 times, 4 goes into 12 3 times. Okay, and then this radical would just all be left inside. So that would be your final answer. Just bring that down for that one. So hopefully you got those 2 correct. Okay, like I said, you could do the factor trees for both of them. You'll have a group of 4 3s, so 3, 3, 3, 3 times 2. So that group of 4 gets to come out, so 3, and then 2 stuck on the inside. So we've done the numbers before. So either way, how you want to do those, I think this is more efficient, more quicker for quizzes and tests, but that's how you would simplify each of these.